Hello and welcome. Greetings of the day to everyone. The authors and invited guests, welcome to Technical Session 7D. Myself Prashi, and this session will be moderated by me. On behalf of Global Knowledge Research Foundation and GR Scholastics LLP, it is my great pleasure to welcome you to the 10th International Conference on ICT for Sustainable Development ICT4SD 2025, Goa, India. The 10th edition of this conference is being organized in a hybrid mode. The physical event is being held today in Goa, India, and the virtual event is being held through Zoom from 17th to 19th of July 2025. I hope you will enjoy the knowledgeable and interactive session through the day. In this session, we have 10 presentations. Each presenter will be given 10 minutes for the presentation and 2 minutes for question and answers. On the ninth minute, I will be raising a gentle reminder. There's another request to all the participants that you stay connected to us till the closing of remarks. If you have any queries or any updates, then you can write it to me in the chat box given down below. Just before we start our session, I would like to introduce you all to the chair for this session, Professor Ronak Kumar Patil. Professor Ronak Kumar Patel is an assistant professor in the computer engineering department at CSPIT Charusat with over 7 years of research experience. Their expertise spans machine learning, deep learning, and recommender systems. His area of interest are Python programming, parallel computing, high performance computing, operating systems, documentation using Linux. He has served as a reviewer for international conferences and has published numerous research papers in esteemed international journals and conferences. We welcome you to the session, sir. Sir, before we start, would you like to say a few words to our participants today?
For the introduction. And congratulations all the participants. You are going to present a paper in this prestigious conference and you are contributing to the knowledge. So, yes, Mrs. present the confidence way and get connected, which is the main motive of this conference. Thank you.
Thank you so much, sir. Now, I would like to call upon our first presenter for this session. Our first presenter is B. Monish Mugar, presenting a paper on the title Benchmarking gRPC Protocol on Various Virtualization Technologies. I request you to kindly take over with your presentation, please.
Yeah, just a second. Yep, ready.
Yes.
Will you be presenting the presentation as well, or
Sir, you can present your paper. You can share the screen.
just a second? All right. Good morning, everyone. My name is Monish, and I'll be presenting the paper Benchmarking gRPC Protocol on Various Virtualization Technologies on behalf of my team consisting of Akshar, Avnish, Mohanish, under the guidance of Prafula Tamam and Subramaniam sir. So gRPC, a high performance RPC framework, has gained a lot of traction for its efficiency and language neutrality, especially after a lot of organizations have made the move to microservice architecture. However, its performance in resource constrained environment has not been explored a lot. So this is where our paper comes in, and we try to evaluate gRPC on different virtualization technologies, especially focusing on metrics like throughput, latency, and resource usage. So RPCs have emerged as the go-to communication protocol in distributed applications and microservice architectures. And this is because REST, unlike REST, which was built over HTTP one, gRPC is based on HTTP 2, which allows for multiplexing of streams. And also, RPC in general is lightweight when compared to REST. And due to the multiplexing of streams, gRPC also supports different call types like unary, client streaming, and server streaming. which gives the developer more flexibility in terms of the types of applications that they can build. Now, let's just have a quick overview of the different types of RPCs that are available. First off, we have Unary. Unary is very simple. The client initiates the RPC with the method name and request message, and it gets back a response from the server. And next up, we have client streaming. Here, the client initiates the RPC with the method name and method data, and streams the request message to the server, and gets back a response in return. Server streaming, RPC initiated by the client, and it gets the response, and the server streams the responses back to the client. And bidirectional, here the RPC is initiated by the client, and it can stream a bunch of messages to the server, and the server can stream the responses back parallelly. Coming to virtualization technologies we have explored, first off we have Docker. Docker is an open source container runtime that helps manage containers and helps manage containers. So Docker containers in general are isolated processes, and they're highly isolated in the user space using C groups and namespaces, but they share the same host kernel. gvisor is also another container runtime, but it's more isolated than Docker because it uses a user space kernel that handles all the syscalls, and in general, and it reduces the interaction with the host kernel, which making it more secure than Docker. Next up, we have Firecracker. So Firecracker was introduced by AWS for their serverless compute products. So Firecracker is based on microbiome technology. So it basically launches lightweight virtual machines that have very minimal overhead, and each microbiome has its own lightweight kernel, making it extremely small and fast to boot. Next up, we have NanoS. NanoS is a unikernel, POSIX compliant unikernel that yeah, it's a POSIX compliant unikernel, and unikernels in general are tiny single-purpose VM images that combine your application with only the essential OS library and drivers. So this makes unikernels in general very extremely small, and they offer fast boot time and also come with enhanced security because of reduced attack surface. Coming to the testing setup so all the tests were run on a Ubuntu server with 64 GB of RAM and AMD EPYC CPU, and KVM and QEMU were set up on the servers to help run the different virtualization technologies. And we also had a client that interacted with the different gRPC services and helped in benchmarking them. So the tools used were as follows. GHZ, it's a gRPC benchmarking and load testing tool. So this acted as a primary client that interacted with the gRPC service. Next off, we used PS utils to track the CPU and memory usage. And then we had pprof that was used to profile the services that were written in Go for any performance bottlenecks. And then perf was used to get an insight into the Linux kernel during the execution of each service. Now, coming to the services we have implemented, all the services were implemented in Golang, and we had implementations for all the different types of RPCs. So, first off, for the Unary, we had a service that took a number and returned the nth prime number as a response. Next, we had for client streaming, we had a service that took a stream of numbers and then sorted the stream of numbers using insertion sort and returned the median of the numbers. And for service streaming, the service took a number and returned all the prime number and returned a stream of all numbers, all prime numbers less than the given number. And for by streaming, we had a service that took a stream of matrix rows and then responded with the rows of the inverse of the inverted matrix, basically. And each service was tested across small, medium, and large workloads that varied with respect to the concurrency and request and the number of requests. Apart from this, each service had the equal amount of resources allocated to them. That was eight CPU cores and 16 GB of RAM, and all of them were configured according to whatever was recommended by the developers of each technology. But except for NanoS, which had to be run in the default mode because it was the configuration that was recommended by developers was not reliable, and it couldn't give us consistent results. So coming to the results and discussions, first off, let's talk about memory. So this graph is a yeah, it talks about the memory usage, and as we can see, the red one, that's Firecracker, and it has the highest memory usage when compared to all the other technologies. And then we have followed by NanoS, and then gvisor and Docker, and this trend is same across all the types of RPCs. Now coming to the reason for this, Firecracker, as I mentioned earlier, has its own minimal kernel, has a very lightweight kernel, but still, end of it has a kernel that loads a bunch of stuff to the memory, which increases its memory usage. NanoS also, despite having a minimal kernel, also loads a bunch of things into memory because of its minimal kernel, and that results in more than normal memory usage. Followed by gvisor. Here also, gvisor uses its user space kernel that results in the memory usage that we've seen. And Docker has the lowest because it does not have to load anything, and it depends on the host kernel. Coming to CPU usage, Firecracker consumes the highest amount of CPU when compared to all other types, followed by Docker and OPS, which almost have the same, and NanoS, which almost have equal CPU utilization. And another thing we observed was service calls. Unary service in general had a higher CPU utilization because of the synchronization that happens between all the Go routines that were spawned. And another anomaly we observed is gvisor. So gvisor's CPU usage in general are tended to be constant in client streaming and server streaming, and not varying a lot, even with increase in workload. Now here, so let's go head to the latency part. So here, this diagram just summarizes average duration across technologies and workloads. And so the conclusions in general is as follows: Docker and Firecracker have the best latency performance, and Docker is slightly better than Firecracker in certain situations, but they both are on the same level. Then followed by gvisor, which showed best performance in client and server streaming, but it does not perform well for Unary and byte streaming. And NanoS consistently performed the worst in all scenarios except Unary, where it was second to gvisor. And the reason for Nano was performing so bad was the use of the user mode networking backend used by Qemu. So this resulted in all the networking part being handled in the user space, which resulted in lower throughput. But we had to do this because using a faster bridge mode networking resulted in Nano's crashing and dropping packets because of its short TCP packet buffer. So yeah, this was unexpected, and we had to go to user mode to keep the test reliable. And in conclusion, Docker has the best performance in terms of both latency and resource utilization, but comes with the drawback of uh, not being very isolated and sharing the host kernel. Followed by Firecracker, which has similar performance as Firecracker, but consumes higher resources, especially memory and CPU. And but the memory consumption can be reduced by using balloon drivers, which reclaim memory and optimize resource allocation. Followed by then we have gvisor, which provides the best isolation, but the performance also takes a hit. And then we have NanoS. NanoS is promising, but looks like it's still in development. And yeah, its performance would have been better if it was able to handle the bridge mode networking. And overall conclusion: Docker is the most balanced solution out there. But if you have a specific requirement of having higher isolation, Firecracker and gvisor is the way to go. Firecracker has higher resource utilization, but has the best performance when compared to gvisor. But if security is of top importance, then gvisor is the best. Thank you.
Thank you so much, sir. Professor Patel, do we have any questions for sir?
No, madam. Nice presentation.
Thank
Okay, sir. Thank you so much for your presentation. Now I would like to call upon our next presenter for the meeting. Our next presenter is Aryan Goyat, presenting a paper on the title Deep Learning and Beyond, Innovations, Limitations, and the Road Ahead. I request you to kindly take over with your presentation, please.
Yes. So, good morning, everyone. I'm Aryan Goyat, a first year BTech student, and I'm here to present my review paper actually on the title Deep Learning and Beyond Innovations, Limitations, and the Road Ahead, co-authored by Aditya Man and my teacher Vimi Malhotra ma'am. Let's explore how deep learning has evolved, its current applications and limitations, and the future directions. Introduction. Deep learning is a powerful subfield of AI that uses layered neural networks to process data. Unlike traditional ML, which requires manual feature engineering, DL has a very amazing features in which it directly takes features from the raw data. It is at the heart of technologies of self-driving cars, medical imagining, and virtual assistants, which we use in daily life. It is called deep because it has layered data sets. It is just like our human brains, in which we learn from patterns and and come up with solutions based on our previous understandings, patterns, observings. It is same like our brain. Motivation. So why deep learning? Transitional ML often struggles with complex unstructured data like image or audio. DL handles this efficiently and perfectly. Landmark systems like GPT for our audio images and our AlphaGo for gameplay have shown DL's exceptional capabilities. But beyond performance, the real push now is towards building models and not just powerful but also interpretable and ethical. So, what's the need in today's world? Uh, we have we live in a world which is data driven. So with data coming up from everywhere, like IoT devices, social media, healthcare systems, manual processing is no longer feasible. We need a data automated system which can learn from the data in real time and make smart decisions which we can rely on. That's where deep learning comes in role play perfectly. So evolution of DL, where did it start? uh, Deep learning has come a long way. It started with the perceptron in 1958 and came through with the deep brief networks in 2006 and to the AlexNet in 2012. Since then, architectures like CNNs, RNNs, transformers have emerged, each suited for different tasks, which we are gonna see in the next slides. So deep learning advantages versus limitation. DL has clear strengths like ability to learn from large data sets to amount of data which we saw, but yes, it's not perfect. It is resource intensive, needs a lot of labeled data, which takes time, and it is also decision making is often opaque, making it hard to interpret or trust with sensitive data like medical healthcare or private data architectures. This was what I was saying. This slide is very interesting. DL is a clear strength, which I told you. DL uses different models for different problems, like CNN uses for image detections used in field like uh, uh, images where used in medical field images to get what disease diagnosis, etc. And RNNs and LMCs handle the speech sequences, and transformers are now dominating NLP tasks due to the parallel processing capabilities. Applications. The impact of DL is massive in image processing. It enables object detection in medical image analysis, as I told you, with using CNNs. In NLP, it powers transitional and chatbots. It's also used in robotics, cybersecurity, and even drug tests. Benefits of our deep learning. It is very beneficial in automation. DL learns without explicit rule, as I told you. It can be used across domain to adapt new tasks easily, especially with a number of transfer learnings, with pre-trained models and fine-tunes for our new problems. Yes, this is deep learning. Challenges in DL. Despite its power, DL comes with challenges. It needs large data sets and high-end hardware. It also suffers a black box problem, in which decisions are hard to explain. Plus, it has issues with data privacy and bias must be addressed. These challenges are little to seen, but are great in our field. Data distribution in DL. This figure shows how data imbalance affects DL models. In our real world data sets, some classes are overrepresented, which can bias our model. We need technologies like augmentation or synthetic data to fix these problems. Uh, Data challenges, a closer look. Consume Creating labeled data sets is time consuming because we have to arrange every data in its particular field. Data imbalance can skew model outcomes. Solutions like federal learning data augmentation can help. Solution federal learning helps to train model across multiple systems without compromising with our privacy, which is a very good thing. So these solutions are the ones which we can look in our future to be evolved. uh, Methodology and key innovations. Some exciting innovations are emerging, like explainable AI. This is very interesting, like SHAP and LIME, which helps us to understand the model decisions. Federated learning enhances privacy. Neural networks and search and model pruning improves efficiency, especially for the edge devices. Benefits of innovation. So these advancements make DL more transparent, are privacy friendly, and boosts DL models. uh, Compressed models now run on smartphones and IoT devices, which we most commonly use. Like if we open our phone, we open ChatGPT or image, we upload our image on Google and say like, if I have a rash and I upload it, so it would tell me what to do. It's a home remedy useful, or I need to consult a doctor. That's where deep learning came in role play perfectly, and we use in our daily life without knowing that it is deep learning. So these compressed models now run on smartphones and IoT devices, enabling real-time AI applications that were impossible a few years ago. Come on now, who think that before a few years that we will type something on, so give a photo on Google and it will give us solution ready. Growth of DL. So by seeing this chart, we can easily say that DL has surged over a past decade, especially after 2015. With more data, better algorithm, and hardware, its growth has no sign of slowing down. You can see the chart. The line is more steep than my grades. Future roadmap. Future lies in combining DL with reinforcement learning, uh, symbolic reasoning, and even quantum computing. There is a strong focus on building fair, ethical, and explainable AI, especially as it impacts healthcare, robotics, law, society, etc. At the end, I would conclude with deep learning is transforming industrial by enabling machine learning to learn and think. But we must overcome challenges around data, ethics, trust. These are very important things to be conclude with, because there are some limitations and which need to be overcome. And after that, deep learning is going to boost. The goal is to create AI not just smart but also responsible and accessible to all. Thanks for your time.
Now let us call upon our next presenter. Our next presenter is Ruhi Panjwani, presenting a paper on the title Design Considerations While Building a Multi-User, Multi-Access Web App, a case study on automated weather stations. I request you to kindly take over with the presentation.
I'll be presenting on Ruhi's behalf because he's having some problems. Is it visible?
Okay, wonderful.
Okay.
Thank
Good
you.
morning, everyone. Today, I'll be walking you through a web application we built as part of a research study on automated weather systems, also known as AWS. AWS systems are clear in climate, they are key in climate monitoring, agriculture, and early warning systems. But while the sensors themselves are sophisticated, the data presentation layer often lacks usability, scalability, and access control. So we aimed to develop a secure multi-user we aim to develop a secure multi-user web application that not only fetches and AWS data in real time, but also provides an intuitive and accessible user experience. The presentation will focus on the design principles and architectural decisions that we made along the way. So some of the key design goals that we had to tackle this problem, we had 5 key goals. First was, oh, sorry, 4 key goals. First was that the front end needed to be intuitive so that users from domain experts as well as non-technical staff could easily explore the data. Second, real-time data should be accessible and visualized as it flows in. Third, users should be able to interact with the data through plots and filters. That is, it should be interactive and not static. And finally, the system should be scalable, both at the backend and the database level, to accommodate more stations and users in the future. So coming to the UI, UX, and front-end framework, we chose React and TypeScript. The reason for this was that TypeScript offers static typing. One of the problems that we faced while using JavaScript is that a lot of times it lets you, it doesn't really have much type checking or any type checking actually, and it lets you refer to objects that don't exist yet. And things like that, they cause problems down the line. So TypeScript helps with this, with static typing, and it helped us catch bugs early and improve maintainability. React's component-driven approach allowed us to create modular, reusable UI blocks, which again helps with the development timeline. And we put a lot of thought into accessibility and color psychology. We chose schemes that are visually distinct and accessible for those with disabilities. Lastly, responsiveness was very important to us because our website is fully responsible. So it adapts seamlessly from desktop to mobile devices, which is quite important for field use. This is a rough design sketch of where we started from with the interface. We'll show you what the final one looks like later. But we have a data display section, which shows our key metrics like temperature, humidity, etc. And you can pick which one you want to see. Then a graphical section, which shows the trends like day-wise, week-wise, month-wise. Uh, Moving on to data retrieval and handling. So we use GET requests to fetch the data from the server where it's stored. And the format that we chose was JSON, that's JavaScript object notation, for its compatibility and ease. We used React use state. We used that hook and we optimized performance using client-side caching so that users don't have to wait for fresh fetches every time. This made the app feel responsive while reducing unnecessary load on the server. So we will take over from here.
Yeah. So as I was saying, the main considerations for the graph plotting included that we need to keep the UI clutter free, and we should be able to observe the graphs and use the historical data for comparing. So this will help the users not just see raw numbers, but actually interpret the trends that are following. Could you please move to the next slide? So, from our rough sketch, this is this is a snapshot of the final web app, sorry. And this is a line-based area fill graph, which helps the user visualize the trends in the temperature data. And we also have interactive buttons over here that let you trigger the different graph views. It shows you the current temperature as well as the average. And so this was our transition from a sketch to a working UI. So the next thing is database and access control. On the backend, we use MongoDB. So the main advantage of MongoDB is that it's schemaless. The document structure is perfect for weather data that might evolve to include new sensors. It's highly scalable and it works well with distributed systems. For access control, we used RBAC, which is role-based access control. So the admins can add stations, scientists can download raw data, the public users only have a read-only access. This ensures that the model has both security and flexibility. Moving on to the future scope, there are several exciting directions in which our project can move forward. One of them being machine learning. So this can provide us predictive analytics like forecasting rainfall trends, Then edge computing for pre-processing data right at the AWS node, reducing latency. Now the system is expandable. We can plug in more stations or integrate additional sensors like air quality monitors. And by adopting open data standards, this system could be made interoperable with other public weather platforms. Uh, in conclusion, this project demonstrates how combining good software design with domain-specific needs can produce a very useful application. This can serve as a blueprint for other sensor-based public data systems. We emphasize real-time access, strong UI UX principles, and scalable architecture. It not only meets our current monitoring needs, but also lays a solid foundation for future enhancements. We hope that this work contributes towards better environmental intelligence and more informed decision making. Thank you so much for your time. Please, I would be happy to take any questions.
Thank you so much for your presentation. So, do we have any questions? Okay. Thank you so much for your presentations, both of you. Now we'll just move on to our next presenter. Our next presenter Our next presenter is Krishna Sheshat, presenting a paper on the title Dave Together, a real-time collaborative coding platform. I request you, if you are available with us, kindly take over with your presentation, please.
Yes, am I audible?
Yes, you're audible.
Okay. Is my presentation visible?
Yes, it is visible.
So I'll be starting the presentation. So we have built a research tool for research purposes, Dev Together, which is a collaborative coding platform in which all the people can collaborate and code together and execute the program at one instance at the server side only. This will help them in prototyping and building tools faster. Uh, so our problem statement arise when we were doing a hackathon, but at the end moment we had to have multiple git merges and we broke all the code at the end. And the end point we were crunching so that it could have been a working prototype. So for this problem statement, we built a tool which will help in collaboration with different with our teammates better, in which we can see what code they are writing. We can fix it at that point only, and it will help others stay in loop as well. So this was a problem statement, and we tried to build a tool for this. So our literature survey for this was to bring what all we will be needing to build this platform. So first of all, we will be implementing collaborative features for coding. But we on researching, we found out that if we are building a collaborative tool, but we have to move on to different collaborative tools for chatting and video chatting, it will be a hamper, and different tool users can cause fragmentation in ideas. So we have implemented the video chat and chat functionality into this tool as well. We have implemented code locking and Git implementation so that we have version control over our projects while prototyping different tools. And we have also implemented safe error passes, so the files are saved when they are error free, and the others can execute while you are editing in it. So this was all needed. There are other studies which shows that there is need for implementation, and there are questioning if there is any need for in switching between platforms while you are working on the same projects. This was a literature survey. And in this, we get to know what all IDs we can use. We were thinking of implementing it within the VS Code IDE, so as an extension. But we found out that it would be a better idea to create a web-based IDE, which can be accessible through the link and everything to be hosted on the server. So everyone can access it at any time. If it was IDE based or local based, it will have to be shared again and again, like the live share feature in the VS Code. So this is a system architecture. We have notification services if there is any meeting going on, if there is anyone joining our collaboration. We have implemented Monaco editor and the code mirror editor for with WebSocket for collaborative features. We have implemented WebRTC for the video and voice chat and chatting features. We have also implemented Git and version control with our databases and the MongoDB for file management and Git control. We have also implemented Gemini features chat for at the end for better work availability. So there is no need to go onto different AI-based platform for asking questions. The authentication servers works with the MongoDB so that they can collaborate on the same project, and the terminal also is shared for them also. So what will happen if someone one is executing a command, it will be available and ready to see for others as well. So what we have implemented for terminal is XTerm.js, which will emulate the terminal on the front end and tell the commands to the back end, while ensuring that the same streaming is done for all the people in the collaboration. The saving feature, the files will be saved in the cloud, and on the next time when others join, it will boot up and the files will be loaded automatically. We have tried to implement and mobile support. We have made it responsive so that the collaborative features are available on the mobile as well. The video chat, the coding, and we have implemented Jamboards for better prototyping and better uh, we, to better visualize the ideas. We have implemented AI-powered chatbot, code-aware replies, video chat, and other debugging tools. So this is a platform. As you can see, when someone writes anything, cursor appears that to tell who is writing. They can have multiple files open. One can work on one file, other can work on other file. They both can work on the same file, just like you see in Google Docs, as you can see other people collaborating. Uh, then this is a Gemini implementation. You can ask question about your files over here. Then this is the video and voice chat feature. You can share screen, you can voice chat, video chat, as well as there will be text chat feature. This is our Jamboard. In this, we can visualize a problem statement, our prototyping needs. They can all will be able to edit and delete over here, so it will be easier for all to see rather than sharing the screen and showing one, then other will be sharing. We have implemented this feature which will reduce the latency and make it smoother for everyone to see and visualize the project. This is the terminal which will be streamed to everyone on this collaborative room. As you can see, I have executed a command and it has run. And it is for now this was local hosting, so you can see it was using my user as Krishna. Summary in we have implemented real-time collaborative. It has Jamboard for collaborative drawing and visual aid for the learners, and implement multiple users so that they can have collaborate easier. Dedicated terminals so they can execute and build upon any code foundation they want, video chat for better collaboration, and file storage for each room, each separate project for the users. At this point, we realize that this project can not only be used for our prototyping purposes, but also for educational purposes. Like teacher can show through Jamboard that how algorithms are visualized and all that, and through coding, teacher can show how code is written and executed, which will be streamed to everyone with less latency than rather screen sharing. In conclusion, we have built a real-time collaborative platform with version control and communication tools for faster prototyping purposes. Thank you. If there are any questions, just
Thank you so much for your presentation, sir. Professor, do we have any questions for him, sir?
No, madam.
Okay, thank you so much.
thank
Thank
you.
you so much, Mr. Krishna, for your presentation. Now I'd like to call upon our next presenter. Our next presenter is Subhashi Chaudhary, presenting a paper on the title Empowering Communities Through Democratic Crowdfunding Decisions. I request you to kindly take over with the presentation, please. Ms. Chaudhary.
Yeah, let me share my screen. I hope it's visible.
Yes, ma'am, it is visible.
Yeah. So, good morning, everyone. Our title is Empowering Communities Through Democratic Crowdfunding Decision, and the paper ID is 814. So, I would like to begin with a quick overview of our research. So, most blockchain based crowdfunding platforms focus on collecting donations but offer very little transparency around how the money is used afterwards. So, we identified this gap and by analyzing DApps and smart contracts, and we found out that donors are typically excluded from fund allocation decisions. So, that's where our work comes in. So we propose a decentralized voting model that uses eigentrust algorithm, allowing donors to vote on how funds are being used while preventing collusion and manipulation. So this approach replaces centralized control with community-driven governance, giving a donor a bigger role, building trust, and making the system truly transparent. So now let me walk you through the main objective of our research. So first up, we wanted to make fund uses more transparent. Right now, donors have no idea where their money goes after donating, and we wanted to change that. So to make the donor voting meaningful, we introduced the eigentrust algorithm. So it gives more weight to the donors with good histories, so credible voices count more. So we wanted to prevent manipulation like fake identities or coordinated voting. The trust system helps us to do that by scoring their credibility. Another big goal was to remove intermediaries completely. Instead of relying on central bodies, we use blockchain and smart contracts to manage everything securely and automatically. So funds are only released when the milestones are met or the community votes in favor. No delays, no manual approvals. So in the end, our aim is simple: build a trust based community led crowdfunding platform that's fair, transparent, and inclusive. So as you can see in this diagram, that the problem is real and actually very simple. The creator creates a cause, the investor invests in the cause. So there is no question asked afterwards. So, before diving into our solution, let's explore some key findings from existing literature on blockchain based crowdfunding. First up, the smart contracts are vital. They automate fund releases based on community votes or project milestone, removing the human bias. Decentralized crowdfunding models lower the barriers for participation and makes it more easier for global donors to get involved. DAOs, or decentralized autonomous organization, are essential for building transparent and community-led governance system. Next up is identity verification that helps reduce fraud by validating both donors and project creators. And lastly, the trust models like eigentrust are crucial in decentralized systems because they give voting power to trustworthy donors and help prevent civil attacks or collusion. Now I would like to hand it over to Arnav Shukla. Wait a minute. Let me mute myself.
Yeah, hello. So our proposed solution is as follows. So what we have simply done is that with the help of blockchain, we have introduced the concept of DAO into this whole system, in the system of crowdfunding. So what we have done new is that now, as you can see that, as you saw the traditional model, there was a creator who creates the project and an investor who invests in the project. Now the new thing which we have done is that all the funds which are invested by the investor into the project are held in a escrow, and these funds are not given directly to the creator. The creator had to first make a request that he or she is going to use the funds in for this so reasons, and the all the investors who have invested in in that project, they have a voting right on the project, and they can decide whether they should give their fund to for this reason or no. So it could be as simple. Let's say the creator is a NGO who cares for dog, okay, and he created a project and he wants to feed some stray dogs some Parle-G biscuits, or let's say some pedigree biscuits. So he can make a request on this platform, and the creators and the investors who have invested in the whole project, they can vote upon whether should we allow this person to give these foods to dog or no, or let's say if they want to give them something else or no. So if the request gets approved, the fund will be transferred to the creator, and if the request doesn't get approved, the fund will be not transferred to the creator. The creator has to create new requests, then and the investors, when they approve, then only he will be receiving the funds. Otherwise he won't be receiving those funds. So simply with the help of using blockchain, smart contracts, and identity for secure, transparent fund management, what we have done, like we have built a whole trustworthy system where each creator can be trusted and each investors can be aware, be sure that the money which they are investing into a project are being are very secure, and they are not being cheated, and the creators also get more credibility in these ways. So the all actions are in this whole system, all actions are recorded in a public ledger, promoting transparency and accountability. Thus, it builds a stronger trust between donors, creators, and improving engagement and platform success. The limitations which we face were like technical complexity, because there is a very steep learning curve, because this is a very new thing where people have to learn to how to vote and how to get their funds and all some legal terms. And there is also scalability issue, because blockchain is famous for its high gas fees. Okay, so whenever the network is having a large amount of users, the are having a very slow throughput. So that's why a scalability issue can happen. And then some regulatory issues like the blockchain and everything, like in different countries, they happen in a very legal gray area. So this is a very regulatory uncertainty which we have. So in conclusion, our research introduced a trusted weighted decentralized governance model for crowdfunding using blockchain and address algorithm, ensure tampon-proof fund allocation, fraud prevention, and community-led voting via smart contracts. And we boost the trust between transparency between the creators and the voters by eliminating any intermediaries. So this all happening directly. There is no intermediate bank involved. There is no intermediate platform involved. It's all happening directly. The future work we can do here is like we can integrate layer 2 scaling roll-up sharding for performing cost efficiency, and we can also adopt a proof of zero knowledge proofs for secure private identity verification, and we can position our whole application as a scalable, secure, and community-centric crowdfunding ecosystem. Thank you.
Our next presenter is P.S. Sriharsha, presenting a paper on the title Human Resource Blockchain Intelligence Recommendation System. I request you to kindly take over with the presentation, please.
Yes, ma'am. Thank you. Yeah, good morning, everyone present. So this is Shriyasha from PS University. So I'll be sharing my screen once again. Yeah, so we are paper 832. Like we are here to present human resources blockchain intelligence recommendation system. So we are talking about a convergent solution fusing distributed ledger technology with advanced AI, precisely engineered for HR transformation. This is not just improvement; it's like architectural blueprint for next generation recruitment. So yeah, I'll be continuing with the problem. So let's confront the systematic vulnerabilities inherent in today's conventional HR and recruitment landscape. So, like the main problem is centralized databases, which are a critical attack surface prone to data breaches and lacking auditable transparency. This fosters subjective decision making and privacy compromises. So, the key takeaway is to in the status quo is that it compromises organizational data, fosters poor candidate job fit, and directly impedes operational efficiency. And also, the core issues include poor candidate job matching, lack of transparency and privacy, vulnerable to data compromise, as we discussed, and inefficient and time consuming model. So, although the conventional methods present various problems such as identification of right audience, like biases in decision making, and most importantly, risks in handling data that are often vulnerable to leakage or hacking. So, what is our solution to this? It is HRBIRS. So, our response is a robust hybrid framework engineered to fundamentally solve these challenges. We leverage today's blockchain's decentralized architecture to deliver inherent transparency and unaccessible data security, directly resolving long-standing privacy concerns. Concurrently, our hybrid recommendation system engine dynamically optimizes candidate job fit. So the key takeaways here are HRBIRS directly boosts organizational credibility, enforcing data integrity, and enables unbiased talent acquisition through features like peer endorsement. So blockchain is evolving technology, providing transparent and secure data. So privacy issues are solved by decentralized architecture. The key differentiator in our model is that it incorporates peer approval and endorsement systems within the organization to significantly mitigate like the inherent biases in selection. Uh, okay. Uh, so yeah. Uh, Here are the core models which are used by our system, HRBIRS. So the first module is applicant data and processing. So this is where this is the UI place where the candidates submit information such as their name, description, skills, years of experience, all the data. It is then processed to extract essential details. So the blockchain we are using, it is Ethereum. Ethereum provides proof of stake model, which provides secure tamper-proof immutable storage for all applicant and job related data. This is validated by POS consensus mechanism. So applicant data submitted by structured forms undergoes initial processing before secure inscription into our proof of stake blockchain network. This immutable ledger also hosts HR posted job descriptions. This directly feeds directly into our hybrid recommendation system. This integrated architecture ensures end-to-end provenance, cryptographic integrity, and algorithmic precision at every stage. So the hybrid recommendation system poses like a compilation of data and maps it to the existing job descriptions posed by HR. So this is how like recommendation system is integrated into blockchain models. Yeah. Okay. Now more into technical foundations. So HRBIRS is not merely conceptual, it's like rigorously implemented system fortified with multi-layered security and components fostering hybrid recommendation approach. So our ML module employs TF, IDF vectorization and cosine similarity for robust textual content matching integrated with collaborative filtering to address cold start issues. The blockchain model, on the other hand, utilizes Ethereum, Solidity, smart contracts for decentralized logic and features a hybrid storage paradigm. So this features a hybrid like sensitive data hashes into on-chain and large raw data securely off-chain in IPFS, interplanetary file system algorithm using GDPR compliance and security. So this dual takeaway from this is that like the dual module design guarantees high precision recommendations within a cryptographically secure and compliant distributed environment. So the system is structured into two modules, which are the like basically two pillars which provide inputs to the smart recruitment. Okay, coming into the implementation, yeah, implementation and security part are yeah. So the blockchain is built on Ganesh nodes for a reliable and decentralized environment. Our smart contracts undergo audits to preempt critical vulnerabilities like reentrancy attacks. And furthermore, each data transaction is secured with SHA 256 cryptographic hashing. This guarantees data integrity. The key takeaway from this implementation is that the like the hybrid storage approach delivers data security. Well, it's the Ganesh and smart contracts strictly compliances to data privacy regulations like GDPR, keeping high precision through recommendation model. The implementation ensures secure data storage which scales according to system needs. Yeah. This is like the correlation matrix which we have done through pre-processing of our data sets, like job description and HR details. And this is some of the insights we have gathered. It's in the paper. Okay, coming to the key algorithms we have used, like the algorithmic intelligence driving HR BIRS and its tangible operational outputs. Yeah. Are two core algorithms. The first one being a hybrid recommendation algorithm, which orchestrates like precision candidate ranking by combining TF, IDF, and cosine similarity for content-based matching and collaborative elements. The HR profile addition algorithm secures profile onboarding via SHA 256 hashing. So the system's functionality is empirically validated through figures showcasing backend initialization, UI data visualization, blockchain mining confirmations, and compelling applicant matching results. So this paper worked on applicability of text similarity methods for matching candidates to jobs such as TF, IDF, and cosine similarity, with the intent to create better match of candidate skill to the requirements of a jobs role. So yeah, also I would like to share the like demonstrations through our paper. So this is the yeah backend where the server is being initialized. So the data, the user data is being sent to the server, and then server responds to store this into blockchain. So this is the raw data which is being stored into blockchain as a JSON file. Also, you can see in our Ganesh GUI, this like this block is being mined, and so and so value of gas is being used. So once the like block is being mined, a specific smart contract is built and utilized for blockchain. And here we can see the application being run.
So if you're showing a video, we are unable to see it.
Uh, Sorry, 1 second. Yeah. Is it visible? No.
Yeah, now it is.
Yeah. Yes, ma'am. So this is where like we are running the backend server, and yeah. So once it is being run, like the data is being collected through UI forms from the front. Like here it is Harshita and her email and password. So this shows that this data is being stored in the server, and post it being served, like there is like another UI form to upload their details. So where all this form details are being filled by the candidate, and then it's being responded from like a backend server as this. So the resume uploaded is this, and so on. So data is being extracted from the resume. And once this data is being extracted, the data can be like block mined can be observed through Ganesh GUI. So here is like the amount of gas being used and what date it is mined on as such. So the transaction can be captured through block like backend. And also this is like the UI of applications where you can select job description and matching details. So it's like select gives you number of candidates suiting for this based on skills match, experience match, and education match. Okay. So that was like the core illustration. Yeah, coming to conclusion and definitive conclusion, like HRBIRS establishes a new paradigm for HR talent acquisition. We have demonstrated a fully validated, secure, and decentralized recruitment framework leveraging immutable power of POS blockchain alongside intelligent recommendation system algorithms. This includes enhanced talent acquisition, followed by TF, IDF, and cosine similarity, and highly effective matching achieves like superior candidate job match accuracy compared to the previous models existing. This is a secure and compliant model which ensures like unparalleled data security through cryptographic measures and hybrid storage, which adheres to modern privacy standards like GDPR. And this is a future-ready framework, provides a scalable and adaptable solution poised to redefine recruitment and digital age. So HRBRS fundamentally transforms recruitment by ensuring superior candidate job alignment, cryptographic data security, enhanced transparency, and full compliance, directly addressing critical industry pain points. This system defines the future of efficient and trustworthy talent sourcing. So the system has enhanced HR talent acquisition through intelligent technologies and blockchain. Yeah. Yeah. Thank you for your engagement and attention to our research on HRBIRS. Uh, we would like to take up any questions.
Thank you so much for your presentation. Sir, do we have any questions for them?
Audible?
Yes, sir. Just slightly volume is not there.
Which data set have you used?
Okay.
Data sets we've used are candidate and applicant data sets. So I would like to show them. 1 second. So we have adopted both the data sets from Kaggle. Yeah. So here we can see like job application, job name, company name, JD, the skills, data post, years of experience. Yeah. Website, job function, industry. So all of this.
Yes. Okay.
Yeah.
And you use the collaborative filtering to understand cold start problem. So how you address that?
Yeah.
You used collaborative filtering
Yes.
to the cold start problem. So how you use this?
So collaborative filtering, we have used it in machine learning for processing the data set and then sending it to the server. So let me explain it, and it's in the paper. So like this is the architecture model. So here, this is where pre-processing happens, and um, we are using XGBoost collaborative learning. So this is being sent to server
XGBoost is
to
a
train.
model.
Yes.
XGBoost is a model, machine learning model.
Yes, XGBoost is the machine learning model.
Yeah. You
Right.
said that collaborative filtering you are used for cold start problem. So my focus is on that. How you have incorporated that thing to solve the cold start.
Okay, like first, what we have done is we have trained the data set for like required inputs, and then using XGBoost, we were able to come up with some outcomes. So that we have connected with Node.js in the backend.
So
So
there
it
is
is
a
then
process that
evaluating it.
so there are two perspectives. One is to manage the things,
Yes.
your data and all, so that you are managing with the blockchain and Node.js and all.
Yeah.
Another thing is implementing the models, right?
Yeah.
The XGBoost and then collaborative filtering approach and all.
Yeah.
So question was on that implementation of machine learning and implementation of collaborative cooking.
Okay.
So here basically collaborative, it is taking the similar users into consideration, and because content based it has cold start problem, so it's taking collaborative also here.
Yeah, that is fine, but how you have incorporated, that is my question. Suppose if it is a movie rating, then I can take movie ratings, and then I can find similar users. So what things you are considering to find the similar users? Or
Like I think I previously mentioned, there's like peer-to-peer endorsement happening in the blockchain system, right? So when interaction is like meticulously categorized as applied, interviewed, offered, or rejected, then it is being sent to the like server to analyze further.
okay, no issue.
Yeah. So
And
based on
you have
pattern
used the,
identification
yeah,
and
that's fine.
yeah, interaction similarity.
Okay. And you have mentioned the hybrid approach. You are
Yes. Right.
using collaborative filtering and content-based approach.
Yeah.
So which fusion approach you have used? It's like a concatenation, which ensemble method you have used?
Okay. So we are using interaction similarity scores. So that
That
is
is a
being
different thing.
yeah.
That is a different thing.
Okay.
Which ensemble learning you have used? This one for your hybrid approach.
Sorry, could you please repeat?
You are using the hybrid approach,
Yeah.
right?
Yeah.
Collaborative filtering and content-based.
Yes.
Now, if you these two methods, you need some approach. Which approach you are using?
Uh, no, we are using collaborative approach for like for the data sets which were present. This method we are using XGBoost itself for hybrid recommendation system. Yeah.
Is whether you are comparing the output of collaborative filtering and content-based filtering, or early fusion you are using. Was what kind of thing apply some kind of that is my question.
Yeah.
And you need to combine these two things.
Yeah.
So what you are doing to use this?
So like actually from backend we are running the hybrid recommendation system, and that is being
What
connected
is
by API call.
so you are not implemented the recommended system. You are taking third party help.
No, like so he like I'll just show you the workflow. So through forms we are collecting the data, and through a RAG like you can say this is similar to RAG, like but the only difference is that it like constantly updates through the UI we are giving it through forms. It connects to the like server and checks if the HR is present or not, and then smart contracts implement the further like acceptance and rejecting. So smart contracts carry out recommendations is like the data to recommendation system again. It is like the backend and recommendation system and smart contracts are in a loop.
We can proceed for.
Yeah.
Thank you so much for your presentation, sir.
Yeah. Thank you, ma'am.
Thank you so much. Now I'd like to take call upon our next presenter for the session. Our next presenter is Deepavita Chakrabarti, presenting a paper on the title Intelligent Communication Strategies for Digital Loyalty Program Participation, a study on promotional efficiency in fuel-related retail industry. I request you to kindly take over with your presentation, please.
Thank you so much, ma'am. Am I audible?
Yes, ma'am, you're audible.
Are you being able to see my screen, ma'am?
And we are able to see your screen, however, not the presentation part right now.
Okay.
Yeah, now we can see your presentation.
Okay. Okay. Thank you. Uh, Good morning, all. I'm Dipanita Chakraborty from Haldia Institute of Technology. Today, I'm going to present intelligent communication strategies for digital loyalty program participation, a study on promotional efficiency in fuel retail industry. So, the loyalty program actually what it is, loyalty programs are designed to build a long-term relationships with customers by offering incentives for repeat purchases. In the fuel retail sector, loyalty programs often allow customers to earn points on fuel and lubricant they purchase. These points can be redeemed flexibly through mobile apps or online platforms for cash discounts, free fuel, or other benefits. Digital platforms actually so coming to digital engagement, digital platforms actually make it easier to track rewards, get personalized notifications, and improve overall customer satisfaction. So, considering the research gap, there are some studies in this area, but whatever gap we could find out, that is that the prior studies on focusing on the general customer retention strategies, but there is limited empirical evidences on what drives participation in loyalty programs and what makes promotional efforts efficient. Our study uses both SPSS for quantitative analysis and in vivo for qualitative insights. We identify key variables that influence customer behavior and highlight how strategic communication and digital tools affect loyalty. So, now coming to the research methodology, our study follows a cross sectional descriptive design, and we have used a 5-point Likert scale where 5 means strongly agree and 1 means strongly disagree. So data was collected from 454 regular fuel customers using a structured questionnaire on a 5-point Likert scale, as I told earlier. And we used a convenience sampling method. Data was collected from November 2024 to January 2025. SPSS 28 was used for regression and collinearity testing, and in vivo was used for thematic analysis and qualitative responses. The mixed method approach gave us a comprehensive view of both perceptions and experiences. This is in vivo. The diagram has been generated by in vivo. It is actually that depends on which factors are whenever we are doing the content analysis. It will break the responses of the consumers. We will code it, and the code will these are the coding are will create the sub themes, and sub themes will be clubbed under themes. So in this case we have got 4 themes: exclusive benefit, redemption option, wide acceptance, and digital reward system. You can see that whatever I am talking about, like a redemption, exclusive benefits, digital reward system, and wide acceptance, you can see that these are in bigger fonts. So wherever we are getting the bigger fonts, so those are actually our themes that has been used by the customers repeatedly. So we are giving much more a higher weightage on those words whenever we are coding their uh, responses. So regression equation, how we are getting it, I will come to this in my next slides. This is our conceptual model. So as I said, that may basically 4 themes or 4 constructs, independent variables we are getting, that is digital reward system, redemption option, wide acceptance, exclusive benefits, and with this 4 hypothesis will reach to our dependent variable, that is customer intention to participate in loyalty program. Here we are judging actually 2 dimension. One is customer intention to participate in loyalty program, and another one is that is the efficiency of promotional efficiency, that I will come later. Now, come to the quantitative approach. First, we are considering Crunchback Alpha. This actually measures the internal consistency and reliability, how well the group of items measures the unidimensional latent construct, and the threshold limit is zero point 0.7. So, this is greater than 0.7, that we can see So this is accepted, and this is collinearity statistics. We need to ensure that the independent variables, there is some they are not related to each other. That is, we want to avoid multicollinearity, and that's why we can consider the VIF data. VIF is how much the variance of a regression coefficient is inflated due to multicollinearity, and acceptable limit is 1 to 5. So we can see all the data that we got, whatever has been calculated, that is in between 1 to 5. So this is acceptable. Now coming to the multiple regression analysis, where we have used SPSS 28. So R value, that is the regression value, the limit is between -1 to +1. R square value that we can see, 0.819, that is 81.9% of the variance in customer intention is explained by these variables. That is, we can get a strong model fit. And Darwin-Watson value, that is approximately 2. That is, there is autocorrelation in the residuals, which is a very good sign, and establishes the model. A value from ANOVA was high and statistically significant, indicating that the model overall is a good fit. This explains actually that variance is the model is greater than the unexplained variance. Okay, that is the error. The error is minimum. Whatever we are estimating and what is the actual value, the gap is minimum. That we can get from the F value. And P value that we can see, that is less than 0.01. So this is statistically significant. In the next slide, we can get the T values as well. T values are also significant, and we can see B is the beta, that is the beta coefficients that we can get from the, this is the constant part. I will go back to the regression equation. This is -1.208, the constant part that we are getting over here. And the construct coefficients, that is beta 1, 2, 3, 4, like 0.412, 0.480, 0.365, 0.2291, that we are getting over here. The coefficients 0.412, 0.480, 0.365, 0.291, that we are getting over here. And these all are significant as these are less than 0.01. So that's why. Now coming to the other dimension, promotional efficiency, here also we can see that our major concern is like promotional policies. You can see these will be in greater fonts, larger fonts, staff knowledge, and then perceived value and customer loyalty. So these all are there. Words will be scattered, but the font size is higher. So these are the main, independent variables that are affecting the dependent variable promotional efficiency. This is our model, that promotional policies, staff knowledge, digital engagement, customer loyalty is affecting promotional efficiency of the loyalty program. Now here also we can get a greater than 1 Cronchbeck alpha, as I have said earlier, so not repeating. And the VIF values are within the limit of 1 to 5. And here we can see the R value, that is 0.921, that is 92.1% of the variation in promotional efficiency is explained by the model. And again, Darwin-Watson is near to 0.2. So showing the independence of the errors. We have a high value of F value, high F value, which is showing a good model fit, and P value that is less than 0.01, showing it is significant. And from here again we can get the beta values, the constant part, minus 1.724, that is there, minus 1.724, that is the constant part of the regression equation. And these are the coefficients, beta coefficients of the independent variable or the constructs. So that is there in the regression equation that we can see. In this way we have derived. It is actually derived by the SPSS itself. And T values, that is also showing that the model is significant. P values are, as I said earlier, less than 0.01. So these are also significant. So in this way, we are establishing a good model fit. So while discussing, we can say that actually we are finding that the importance of digital tools and intelligent communication is immense whenever we are considering the flexible redemption, real-time digital reward, or personalized engagement. that can improve both participation and promotional efficiency. Customers feel empowered and valued, which increase the likelihood of repeat visit and ultimately leads to long-term brand loyalty. So satisfied customer, they will be loyal customer, which actually make the venture successful, the promotional venture of loyalty program successful. So we have two part of implications. One is theoretical, another one is managerial. In the theoretical part, empirically, it has been proved by our study that the digital engagement impacts loyalty and it adds value to customer behavior research in the fuel industry. And regarding the managerial implications, we can say that our study will help managers to design apps with the redemption flexibilities, will help them to train staff for better customer communication, and also will send targeted notifications. It will also
Excuse me.
help.
I'm sorry to interrupt. However,
Yes.
we have crossed the 10-minute mark. I request you to kindly conclude our
Sure. So we are considering that to conclude this, we can say that digitally enabled loyalty programs can significantly boost promotional effectiveness and customer engagement. Key drivers include digital rewards, app-based engagement, and personalized communication. Companies should integrate these strategies to foster long-term loyalty and competitive advantage. Thank you for your attention.
Thank you so much, ma'am. So, do we have any questions for ma'am? Okay. Any questions? And sure. Thank you so much for your presentation, ma'am. Now we'll move on to our next presenter for this
Thank you.
session.
Thank you.
Thank you. Our next presenter is Gagandeep PS, presenting a paper on the title Multimodal Playlist Recommendation System. I request you to kindly take over with your presentation, please. Sir Gagandeep. So if you're available with us, I request you to kindly take over with the presentation, please.
Yeah. Am I visible?
Yeah, now you're audible.
One minute. Okay. So let's just, I hope I'm visible and audible.
Yes, sir, you're audible, and your screen is visible as well.
So my name is Gagandeep PS. I am here to present multimodal playlist recommendation system that is our paper research. And so welcome to the jury members and other presenters. So music really influences most of the people in these days, like based on their early mood, like if they are stressed, if they are sad, music plays an important role in giving them enthusiasm and making them feel better in many ways. But mostly the present day recommendation system is based on the history and the recommendation based on the previous searches that is not really effective because most of the time we will have to end up time searching for what we want to listen to make it feel better. That is going to spend a lot of time. But we would want something that would recognize what we're feeling, and based on that, we would want us to recommend the music, right? So for that, we have created this. So not this isn't just a tech demo. It is basically a responsive interacting thing that is recommending the music based on the physical and the facial activities. My initial work focused on detecting emotions through facial expressions and identifying the meditation disturbances. So this basically had a fundamental question struck me, which said, "What if people mask their emotions?" Right. So a person can be sad, but will mask himself saying that he's happy and whatnot. So that is not exactly correct. At the same time, I found myself repeatedly caught in a loop wanting to listen to music that I want to listen rather than just search for it and spend a lot of time. In those moments, I wish someone or something could read me read my mind and choose what I want to listen.
These challenges led me to design a multimodal system that doesn't just rely on your facial expression, but also my inner brain activity, saying what I feel and the physiological signals. So this is what led to this is what led me to this research. So I have read a couple of papers. The first one reading the frontal EEG correlation based human emotions identification and classification. So this study basically told me the areas of the brain that had um, the understanding of the emotions of the brain. So that basically gave me the five basically nodes that said F3, F4, FZ, F7, and AF3. Basically, the left frontal, the right frontal, the mid frontal, prefrontal, and temporal frontal. This showed the brain activity that was telling about the human emotions. Okay. And the paper also had the other two models saying the GSR and the facial recognition. The GSR is the galvanic skin ratio. The skin ratio had four parameters: the resistance, okay, the skin resistance, the skin conductance, the temperature, and the heartbeat. So you might ask me why you're using four different parameters. So when you're stressed and when you're excited, your sweating increases, increasing the heartbeat as well. But that time the temperature comes in saying you are stressed. That shows the domination regarding the uh, which mode is activated. So coming to the EEG signal, after collection of the EEG signal, particularly from the electrodes F3, F4, F6, F7, and AF3, is strongly associated with processing the emotion state, happiness, stress, calm, and uh, sadness. Okay, the neutral oscillation primarily in these regions were quantified using frequency domain analysis via the fast Fourier transform. While the fast Fourier transform provides a general spectrum of frequency components, it lacked precision in isolating specific bands due to the spectral leakage and noise. To enhance band-specific accuracy, we employed a fourth order Butterworth filter to band prior the FFT and give us the proper mood. So the main frequency that we focused on was 4 to 8 hertz that dedicated the drowsiness, meditation, and creativity. 8 to 13 hertz that showed relaxation and calmness, and 13 to 30 that showed happiness and alertness. For the GSR, we collected the four parameters, which is the heartbeat, the resistance on the skin, the conductance, and the sweatiness. Okay, due to the sympathetic activation of the sweat glands, which turns on lower skin conductance, these two signals behave inversely and their combined analysis ensure greater robustness by minimizing false positives caused by factors like dry skin and sensitive. Peripheral temperatures act as mood stabilizers during calm state. Vasodilation leads to stable or slightly elevated skin temperature. While stress or fear triggers vasodilation, diverting blood to core organs and causing a drop in temperature. This enabled us to distinguish between stress and excitement, which were both elevated conductance but differ in thermal response. In parallel, the state variability provided response a dimension of emotion detection, elevated heart rate indicated arousal state like anxiety and excitement. And coming to the facial recognition, we used the OpenCV to collect the data, and we use the FAR dataset, that is facial emotion recognition dataset, or based on the convolution neural network learning, we dedicated the mode. So these were our datasets that showed the stress based on the facial emotion. Then the 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 GSR value gave the mood reading and the EEG gave the mood reading. Based on that, we
weighted mean algorithm that gives the highest priority to the EEG mode and a lower priority to the facial mode and a more lower priority for the GSR mode. And based on that, we got a recommended loads.
Thank you for your presentation, sir. Sir, do we have any questions for him?
In this, have you used content-based or collaborative?
Yeah.
Have you used content-based or collaborative filtering? In this recommendation, have you used content-based filtering or collaborative filtering?
We have used content-based where we collected data and we have made the algorithm.
Okay. So you are just comparing with the user interest.
Yeah, a user data, like what we get from the user.
So you are capturing user interest, which genre I am interested or what is my need.
Yeah, like based on the physical activities and the facial expression, it'll detect what mood he is in. Based on that, playlist will be recommended.
Okay. Thank you.
Thank you so much, sir. Thank you for your presentation, Sir Gagan. Now we will call upon our next presenter for this session. Our next presenter is Gitika Alapati, presenting a paper on the title Speech-Based Robust Telugu Grocery Item Identification Using PLP and GMM. I request you to kindly take over with the presentation, please. Sorry.
Hello.
Hello. Yes, ma'am.
Hello.
Yes,
Is
you're
my
audible.
screen visible now? Thank you. Good morning, everyone. Myself, Geetka Alpati, and I am representing on behalf of my teammates. I take a minute to tell my teammates' names. Professor A. Ravati was our guide and constantly supporting us throughout the project. And Sunitha, Pranay, and myself are the people who are working on this. And our title is based upon speech-based robust Telugu grocery items identification using PLP and GMM. Well, coming to the problem statement of this research paper, it's basically about technique like speech recognition systems are mostly on global languages like English. And there are no speech recognition systems mostly on Telugu languages because lack of databases. So we have created our own database from our friends. Like we have created 200 samples for 20 grocery items. And this is the flow diagram which we have followed. First, we took the database and we did for training. Later, our training, we have did future extraction. In after completion of future extraction, we have done GMM modeling. And at last, the future extracted data from GMM and new raw data we have sent to testing data. At last, while giving it to classifier, we use maximum likelihood classifier. Here we have used and followed different techniques like Weiner filtering, spectral subtraction techniques. While using Weiner filtering, it gave an accuracy of 70%, and while using spectral subtraction technique, we got 20 to 80% accuracy. But while using 80 to 20% ratio method, we got accuracy of 99.07. Here we took a database, and after completion of like future extraction method, we divided the output data into 80% and 20%, where we are using 80% of the data for training and 20% for testing. For training data, we have created models. These models are used in testing data, and while using this at last, by sending the data to testing data, we got a output in confusion matrix. While working on the database creation, we have created all data audios into standard format like 16 kilohertz, 16 bit and mono channel. We are using 16 kilohertz because like human audible speech signal is of 300 to 3.4 kilohertz. So by using Nyquist rate, we converted it to 16 kilohertz, like more than or equal to twice. So we converted it to 16 kilohertz. And for 16 bits, we are using amplitude. For having proper amplitude, we are using 2 power of 16, we are getting 65,000 of amplitude. And for mono channel, to focus on a single audio signal, we are using mono channel. And this speech recognition can be done on speaker independent and speaker independent. Whereas speaker dependent will depend only on one person. We are using speaker independent so that it depends on two persons or multiple people. Well, coming to future extraction. In future extraction, only the required amount of data like caps and all will be removed, and only required data like words, phenomena and all are taken by the model. In future extraction, this is the block diagram we followed. While coming to pre-processing, we use noise reduction techniques, pre-emphasis, framing and windowing. While coming to framing, we are using Hamming window. Because we want about audio signals, so we are using Hamming window. While coming to Hanning, we can use for frequency applications. Here using Raster PLB method, whereas Raster means relative spectral analysis, filter plus perceptual linear prediction. It mimics the human ears hears. And while coming to modeling, we are using Gaussian mixture method, and it is like probabilistic method model used to represent the distribution speech features. It takes every speech or a word into a different type of patterns. These all patterns combine together to form a matrix. Here we are using mixture choices of 16, 32, 64 and 128. And this is the flow diagram we followed, like data modeling, pre-processing, model training and model saving. The models are created only for trained data. This is the output for GMM model. Every cycle, the error keeps on reducing. At last, while all the errors comes like 0.02 and all, we have stopped the process, and it took us like 4 to 5 hours to complete the whole process for only GMM model. While coming to testing, 20% of the future extracted data was sent to testing, and we took models from training data, and by using this we have used maximum likelihood classifier, and we have built like model has built-in confusion matrix. Maximum likelihood classifier is a statistical method used to classify data based on how likely it is used to belong to a particular class, like whether it gives a maximum accuracy and like it belongs to a particular class or not. This is the output confusion matrix what we got. While coming to the first matrix, we used a mixture size of 16 GMM mixture size. While coming to the first row of this, butter and honey has some like, due to this the accuracy was reduced. So we perform cross correlation because to find out whether there are similarities between these signals, and we got a cross correlation, positive cross correlation. So we can tell that there may be some similarities regarding to them. And we have performed for row 5 and column for column 5 and column 10. Here we got more positive coefficients, so we can tell that they are similarities, so that the efficiency for this was 82.3%. And for 32%, we got nice accuracy of 97.13. And while coming to 64, we got maximum accuracy like 99.07. So we can tell that 64 confusion matrix we are considering, and 80:20 method is the best method. This can be used for various applications like voice control grocery items, so that user no need to go and search in the markets. Just you can tell the grocery item name and it will be added to your cart. And automated inventory management, like staff can log it directly by using the grocery items names and check how much stock they are present. And we can use like during COVID, we can use hands-free shopping experience. Instead of going to there, we can directly check the stock and we can know whether it is present or not. So we conclude that 80 is to 20% method we are using, and we have a maximum accuracy of 99.07. These are the references we have used for some information. Thank you. Any questions?
Thank you so much for your presentation, ma'am. So do we have any questions for her, ma'am?
Madam. No question from my side.
Hello.
Okay, sir. Thank you so much for your presentation, ma'am. Now I'd
Thank
like to call upon our next presenter for this session. Our next presenter is Ritika Varanyanam, presenting a paper on the title Speech-Based Robust Speaker Authentication Against Voice Conversion Based Spoofing Attacks. I request you to kindly take over with your presentation, please. Ms. Ritika?
Yes, ma'am. Am I audible and visible?
Yes, ma'am, you're audible. Just stop sharing. Yes, ma'am, you're visible as well.
So good morning, everyone. I, Ritika Vallinayagam, along with my team, Sivaranjani and Deepthi, are going to present our research on voice-based authentication system under the guidance of Dr. Evti. In today's digital world, keeping our data safe is really important. Many systems include biometrics like fingerprint, face scan, etc. But these often need systems that are quite expensive. An easier option is to use the voice-based authentication system. It just requires a microphone and a computer. But there is a problem in this system. It can be tricked by replay attacks. In a replay attack, someone records a person's voice and it is played back to trick the system. So our aim is to design a system that not only identifies a speaker, but can also differentiate between the real audio and the recorded audio. So we have used the AVS spoof data set. This data set is mainly designed to evaluate how the system handles replay attacks. The database includes genuine and attack speech utterances. We have taken 3 types of attacks, which is laptop, phone 1 and phone 2. For a sample, we have taken 10 speakers, 5 male and 5 female speakers. So continuing with the presentation, the workflow is divided into 2 main phases, which is the training phase and the testing phase. In the training phase, we use genuine audio and then we model to extract the unique characteristics of the speaker. In the test phase, we use the test signal, which can be either genuine or spoofed, and it undergoes the same feature extraction process, and these are compared against the stored genuine models. So coming to the feature extraction process, feature extraction is a process by which an audio signal is converted into a set of numerical values. These numerical values represents the characteristics of the loading the audio files. Each speaker has a single audio file. We perform voice activity detection to remove the silent segments of the speech. We use a high pass filter to remove the noise components of the signal. Then the signal is divided into frames of size 25 with an overlap of 10. This is done with the help of Hamming window. that ensures a smooth transition between the frames without any loss. The signal is divided into energy values. This is the values by applying logarithm to the energy values. Finally, we apply discrete cosine transform to the normalized energy values and we get the MSCC features. The final output is a matrix in which the rows represents the time frames and column represents the features. These features are used in the analysis in the future. The next process is modeling. In the modeling process, we apply k-means algorithm to the extracted features. So k-means algorithm helps the system to differentiate between the real audio and the recorded audio depending on how the features are spread out in the data. So the process begins with loading the MFCC features and then we normalize it to ensure uniformity. Then we apply k-means clustering and we get a group K clusters in which features having similar properties are grouped together. The centers of each cluster, called as cluster centers, represents the characteristics of the features which are grouped. Then these cluster centers are saved and instead of using the extracted features, we can use these cluster centers, thereby which it becomes easier to compare two audios. Next is the testing phase. In the testing phase, first we load the MSCC features of the test signal. Then we normalize the MFCC features to ensure uniformity. We segment the signal into frames of size 256 with a shift size of 32. Then we load the cluster center of the genuine audio. Now, for each frame, we compute the minimum distance to all the cluster centers. Based on this, we assign the closest cluster to the frame, thereby which we can identify the speaker. The final output is a confusion matrix that computes the accuracy of the entire process. This is the confusion matrix obtained for genuine versus genuine signal. In this, the test signal and the trained signal both are of the original speaker. The diagonal values of the matrix are comparatively higher than the non-diagonal elements. So the higher value means good accuracy and more similarity between the speakers. But as we can see for speaker 9, the accuracy is comparatively lower. So we perform correlation for speaker 9. So this is the correlation matrix. The anti-diagonal elements are negative, which means that the similarity between the signals is less, thereby which the accuracy for speaker 9 is less. This is the confusion matrix for genuine versus replay laptop signal. Here we are comparing a genuine signal and a attack signal. So the accuracy for this will be comparatively lower. The diagonal elements are lower than the non-diagonal elements. Lower accuracy means the similarity between the speakers is less. But for speaker 1, the accuracy is high. So we perform correlation between the test signal and the reference signal of speaker 1. This is the correlation matrix obtained. The anti-diagonal elements are positive, which means that the similarity between the two signals is more, thereby which they are similarly, this is the confusion matrix obtained for comparing genuine versus replay phone 1 signal. Here for speaker 7, the accuracy is high and we perform correlation for speaker 7 and this is the matrix obtained. This is the confusion matrix for genuine versus replay phone 2 signal. Here for speaker 7, the accuracy is high again and we perform correlation and this is the matrix obtained. The authentication system can be used in wide range of real-world application. like banking, smartphones, access control system, forensic investigations, and many more. So, so to conclude, I'd like to say that our system could handle replay attacks really well. To obtain even more accurate results, we can use MFPLPC, that stands for Mel Frequency Perception Linear Predictive System, which is a combination of MFCC and PLP. So finally, I'd like to conclude by saying that voice-based authentication systems are really safe and reliable if suitable methods of feature extraction and modeling are used. These are the references. So I'd like to thank all of you for giving us this wonderful opportunity. Thank you.
Thank you so much for your presentation, ma'am. So, do we have any questions for ma'am?
No, no.
Okay. Thank you so much for your presentation. So, with this, we come. Yes, sir? Okay. So, with this, we come to the conclusion of our session. I sincerely thank our authors for their excellent presentation and contribution in this session. All our participants for being a part of this international conference. I hope this session was informative enough. We, on behalf of the whole team, thank you for your support during this 10th version and all the previous 9 versions of this conference. We will be happy to have you in the 11th version in 2026. All the presenters would be getting their digital certificate through email within 2 working days. Further, all the papers have already been forwarded to the Springer. The publication will be live within 7 to 8 months. Kindly cooperate with the team of ICT4SD 2025. I would also like to thank our session chair, Professor Patel. Thank you so much, sir, for being our chair for this session.
Thank you, madam, for this opportunity.
Sir, this is a token of appreciation to our chair on behalf of the team of ICT4SD 2025 and Global Knowledge Research Foundation and partners. Thank you so much for your valuable presence, sir.
Thank you.
Now, I just request all of you all to kindly switch on to your cameras for a quick snapshot of this virtual conference we just attended. Requesting all to kindly switch on to your cameras, please. Thank you so much. Stay safe and take care. We meet in the next international conference. Thank you.